How you doing, Donald? Tuesdays and Thursdays are YouTube lessons instead of the Zoom. So we will get started on this in about 2 minutes. If you prefer Zoom to YouTube, you can let me know. Maybe we'll switch back to that. Alright, I'm going to wait about 1 or 2 more minutes to see if people show up, then I'll get started. It is a lot earlier at 11 a.m. as opposed to 2 p.m., so some people might be watching on recording, and that's fine. So about 1 more minute, and then we'll get started here. And feel free to say hi in the chat if you are here with us. Thanks for joining. There we go. Thank you for the catch on the audio, Donald. Alright, so for this week we're focused on slope-intercept form. Specifically, there's a few key terms that we need to understand as we're going to work with slope-intercept form. The first key term is a y-intercept. As we started to learn last week, the y-intercept is the point where a line crosses with the y-axis. And it's really also wherever that point is that's showing you the value for y when our x is equal to 0. So the y-intercept kind of represents the starting point for any of these linear relationships, these x and y equations. The slope, rather than describing the starting point, the slope describes how things change or how they move after that y-intercept. The best definition for slope, or the most basic definition we can have, is it really describes the rate of change for our two variables. And as we're going to see today, there's a couple equations or expressions that help me figure out or measure the slope. If I'm on a graph, I want to use this expression rise over run, and rise over run really just helps you measure how much y is changing compared to or divided by how much x is changing by. Finally, towards the end, whenever we have equations in this y equals form, then automatically whatever number is multiplied with x, which we're calling m here, the coefficient of x, that's going to represent your slope, and whatever number is all by itself, added or subtracted, that will really represent the y-intercept, or the starting point. So to begin for today, we're going to start talking about slope. I'm going to make my whiteboard a little bit larger. And the big thing I want to emphasize with slope is going to be the m in this y equals mx plus b equation. Remember, it measures our rate of change. And when we're on a graph, to measure that rate of change, rise over run, is really the most helpful thing we need. So if I take a look at this first graph here, this blue line that you can see my mouse tracing over, I need to figure out the slope, or measure the rate of change, which says how quickly is the y, the up and down gaining units, compared to the x, the side-to-side movement. And whenever I do slope, I really want to figure out two data points, or 2 points on my graph that I can use to measure that slope. So here, for this first graph, I see it's actually a proportional linear relationship. It starts right at the origin. So I'm going to mark that as the first data point we use. And as I follow the blue line, I see another point right here that's nice right on the corner of a grid box. These are the 2 points I'm going to choose to analyze to measure slope. I see that this climbs up by 2 units. It goes up 2 units, and then it goes right by 1 unit. So we could say it gains 2 units on the y-axis, as the x-axis, the sideways movement, only gains 1. So it goes up by 2 and right by 1. It continues to follow that pattern, up by 2 and right by 1. And because it follows that up by 2, right by 1 pattern, the slope, or the rate of change, y is gaining 2 units, so 2 goes in the numerator, every time x gains 1 unit, so the 1 goes down in the denominator. We're going to take a look now at the next graph here. We see this blue line that's traveling, and this time it looks almost like it's reverse direction. Instead of moving up towards the right, it's moving down as we go towards the right on the graph. So again, I'm going to find 2 data points to be able to measure my slope here. The first data point I'm going to pick out happens to be the y-intercept. You don't have to use this point, but I think it's a great one to always use if it goes through the corner of a box right on the y-intercept. There's other data points I can use too. This one would be a good one. I'm going to mark a few in red. Any of these would be good data points to use to measure slope. I'm going to choose to use 2 points. Specifically, I'm going to use this one right here, that y-intercept, and I'm going to use this one down here. Maybe not the most efficient point, but it'll still work. So to get from my first data point, the y-intercept, to the next one, first I'm going to travel down, not up. And specifically, I go from the positive 2 down to the negative 2 on the y-axis. So that jumps down by 2 and 2 more, or it jumps down by a total of 4 units. So the y has just lost 4 units, and at the same time, the blue line not only went down by 4, it went right by 2 units. And as the x moves right by 2, that's gaining, so I'm going to call that a positive 2. So here we see that we lost 4 units for the y, and we gain 2 units for the x. Now we can simplify that further. Every fraction's a division problem, and negative 4 over 2 simplifies to negative 2 over 1, or we could even just simplify that to say negative 2. So that's how I'm arriving ultimately at a slope here of negative 2. You could delete all of that if you want and just call the slope negative 2. You could call the slope negative 4 over 2. They're all correct. Cool. Donald, thanks for following along. Evan, awesome to see you're here joining us. Hope you're doing well, bud. So we're going to keep moving to the next couple. I'm going to move through these a little more quickly. If you're at home on your own with me live, I'd encourage you to try to figure them out before me. If you're at home recording this or watching after we did this, I would encourage you to pause the video and try to do these 2 on your own before you see me do them. So again, I see this blue line here. I want to use 2 data points to measure slope. Here, part of the trick, when I zoom in and I see that y-intercept, it's not perfectly on the 2 or the 3. It's somewhere in between them. So I'm going to turn that y-intercept down. I don't think it's a great point to use for slope. Instead, I see this data point right here, where x is at 1 and y is at 4. I'm going to use that as one of my slope data points. And I'm also looking for another corner of a grid box on this blue line And I see that right here. So I'm going to now measure from this first data point where my mouse is currently over to the second data point, how far did I have to track up? That's the y change, or the y-axis is growth. And I see it went all the way, sorry it's a little crooked, from -4 to +4, so that's a jump of 4 to get up to 0, 4 more to get to +4, or a total of 8. That's a +8, that's a very ugly 8, I'm sorry. And then you also need to travel to the right. We're lined up with the -4 on the axis. We're going to finish on the +1, so that's a total of 4 and 1 more, or a total of 5 to the right. So here, I see that the x value is gaining 5, and during that time, the y value gained 8. The slope is going to be 8, or +8, over +5. So again, when you're on Khan Academy, IXL, whatever it may be, some of the trickier ones, you got to look closely to find two good data points that are right on the corner to make it a little easier to measure slope on the graph. For our last one, similar situation, the y-intercept is not great, but I do see right here, this would be a good data point to use right on the corner of a grid box, and I'm going to also just use this one that's over up in quadrant 2. I see that it needs to get from this data point on the left to the next one, it has to go down by 1 unit, and it needs to track right by 3 units. So as it moves down by 1, that means that the y has lost 1 unit. That's an ugly -1, but there we go. And as it goes right by 3, that means that the x has gained 3 units. So I've got a slope of -1 over 3. You could write that -1 in the numerator, you could put the negative sign out front. They all mean the same thing, and negative divided by a positive creates a negative. One thing I'm going to point out just quickly as we look back now, we see the two graphs on the right, where they travel down to the right, had a negative slope. So any line that travels down towards the right means y is losing as x is gaining, and it's going to have a negative slope. Alternatively, any line that travels up towards the right, like the two graphs we saw on the left here, even if they have a negative y-intercept or a y-intercept of 0, they still have a positive slope. The y gains units as the x gains units. Hopefully that makes sense for the graphs. For number 2 is a lot like the second Khan Academy assignment this week. They're going to ask you about slope or the rate of change. But now, let me tab back to my whiteboard. Now when I'm talking about slope and they just give me 2 data points the line passes through instead of the whole graph, I think the y change divided by x change definition for slope is more helpful. Rise over run means the same thing as y change over x change. But here for number 2, for all of these problems on number 2, we don't have a whole graph. So visually we cannot measure rise over run, but we can use the 2 data points we're provided with to measure the y change compared to the x change, as you see on my whiteboard there. So for the very first one, the 2 data points that I'm going to write on my whiteboard here, the first data point, x is 1 and y is 0. Very important to know when these ordered pairs, these parentheses list data points, the x comes first and the y is listed second. So our first data point is 1 for x and 0 for y. The second data point is 3 for x and 8 for y. So that's the data points I'm copying onto my whiteboard to analyze or to measure here. And if slope is defined as the y change divided by the x change, that's all this little triangle means. It says how much did y change by and how much did x change by. Then I'm going to go ahead and use the data points, the values, to measure the change. Y goes from 0 to +8, so that gained 8 units. And the x value goes from +1 to +3. It's also gaining value, but only 2 units. So if the y value just gained 8 units, and if the x value gained 2 units, our slope, our rate of change, is y gains 8 per every 2 units that x gains. Every time you have slope, you want to simplify that ratio if possible. Whenever I see 2 even numbers, like 8 and 2, I know they can be divided by 2, each one of them. or 4 over 1. Some of you might have been saying 8 divided by 2 equals 4, so the slope is 4. That's another way to understand the slope here. I'm going to leave my slope as a fraction, as a ratio 4 over 1, but it's totally okay to write a slope of 4 here as well. Based on that, if you're with us live, definitely try to be figuring out the second and third one on your own. If you're at home watching this recording, I would pause the YouTube video and try to figure out the next two on your own before watching me do them quickly. So now we'll take a look at the next one, the next pair of points that we're going to have to use. The line starts out going through 6 and 8, so the first data point has an x value of 6, a y value of 8. And then the second data point, x value is now 7, and y value is now 1. I'm going to again measure my y change and x change to derive or find the slope. To get from 8 to 1, I need to decrease. I need to go down, specifically down by 7 units. And while the y value just lost 7 units, the x value goes from positive 6 to positive 7. It actually gains 1 unit. So our slope ratio is negative 7, or the y is losing 7, and each time the y loses 7, the x is gaining 1. So it's already in unit rate form, or it's already as simple as it gets for this situation. So you could call the slope negative 7. I'm going to call the slope negative 7 over 1, emphasizing that y loses 7 each time the x value gains 1 unit in that line, or that linear relationship. The very last one now, I'm going to skip using the whiteboard. I'm going to just kind of talk through this. I see, as I look at this point, the first point, the y value is 1, and then by the second data point, the y value is down to negative 4. To get from positive 1 to negative 4, I need to travel down by 5 units. If I jump down by 1, I get to 0. Jump down by 4 more, now I'm at that negative 4 I need to get to. So y lost value, it lost 5 units. The x value, meanwhile, started at negative 10, and it went to 0. So it grew. If I go from negative 10 to 0, I've increased value. Specifically, it's increased its value by a positive 10. Get rid of that negative. So the y value loses 5 as the x value gains 10. Hopefully a lot of you recognize the fraction negative 5 over 10 is the same thing as negative 1/2. Totally okay to write your fractions the way I did there. If you want that fancy fraction where it looks stacked on top of bottom, you need to go to insert equation. I'm just going to skip that piece for now because it's totally fine to write my fraction this way. If you've got any questions, put them in the chat. Thanks to those of you who are live with us, and off to a good start. Okay. Now, before we move into number 3, I'm going to quickly review our last key term here for the day. Now that we understand slope a little bit more, which measures the rate of change, and we also recall the y-intercept measures our starting point, whenever you write your linear equations in y equals form, all linear equations can be written in this form where y is all by itself or it's solved for y. Then whatever the m is, whatever is multiplied with x, needs to represent my slope. Let me bring my whiteboard back up. So whatever the m is, whatever is multiplied with x, if it's in this y equals form, whatever the m is represents the slope for your linear relationship. As we're going to talk about the next couple weeks, this is not the only way to write linear equations, but it's probably the most common, and I think it's the easiest to work with. So whenever you see y equals equations, they're in the form called slope-intercept form because it's easy to identify both the slope and the y-intercept when it's in this y equals form. That's what problem 3 gets at. That's what the third Khan Academy assignment focuses on this week. So here we see for all of them, they ask us to identify, let me make the whiteboard slightly smaller, identify the y-intercept and the slope for each of the equations shown below here. So our first equation, the first one we're going to take a look at, says y equals 5x minus 1. And we're asked to identify both the y-intercept and the slope, and they're going to have us write the y-intercept as an ordered pair, wherever it would be found on the graph. So the first thing I'm going to look at is where is the y-intercept in this equation. If I reference the whiteboard, remember the plus b the number that's all by itself that's not multiplied with x is going to represent my y-intercept. And in this case, I see for the first equation, I'm putting a red box around this, the negative 1 is the b in this y equals mx plus b equation. The negative 1 represents the y-intercept. And going back to my whiteboard for a second, you should recall that the y-intercept tells me the y value when x is equal to 0. In other words, if I eliminated that whole 5x term, if we cut all of that out, and 5x was just gone, we made x 0, so 0 times 5 is gone, y would have to be equal to negative 1. So one of the nice things about building these equations in y equals form is that whatever number is all by itself, the b, is automatically representing my y-intercept. The second thing I'm asked to figure out about this y equals 5x minus 1 equation is what is the slope, the rate of change. And if it's built in this y equals form, the m represents my slope. Because here, whatever is multiplied with x, that's going to tell me how much y grows for every x. If I make x 2, 2 times 5 is 10, that's going to pump 10 more value into y. So here, if the 5x is my slope term, whatever x's coefficient is, in our case the 5, that's multiplied with the x, I meant to circle that, not cross it out, represents our slope. And here we would say 5 over 1, meaning our y value gains 5 units every time you bring one more x into this equation. Based on that, if you're with us live, hopefully you can figure out the y-intercept and slope for the next two on your own. If you're watching this on recording, again, I would encourage you to pause right now and try to do the next two for number 3 on your own. If you're with us live, hopefully you're finding y-intercept and slope for these next two. Okay, the middle one is still in y equals form. The y is all by itself, as you see on the whiteboard, and there's a number multiplied with x. In this case, it's a negative 3/4. The tricky thing here, there is no plus b. There's no minus 1, minus 3, plus 7. And the reason for that, it's a plus 0. This is a proportional relationship, y equals kx, as you may recall from last year. And the proportional ones are a special linear relationship that have a y-intercept at the origin, as you should recall. So here our y-intercept is 0, because if I make x into 0, that whole term gets eliminated and y would also be equal to 0. Our slope is going to be whatever multiplies with x. In this case, our slope is that number right there that's multiplied with x. Our negative 3/4 represents the slope. You can put that negative 3 on the top. You could also, more often, you're going to see that negative sign out in front. A slope of negative 3/4 is the same thing as negative 3 divided by 4. Okay, for the last one, and Khan Academy will do this, IXL will do this. If it's in y equals form, the equation is in slope-intercept form. But sometimes they put the b up front and they put the mx later. So it's important, if it's in y equals form, the m is whatever the coefficient of x is, or the slope is whatever x's coefficient is. The y-intercept is always the b, the value that's all by itself that's not multiplied with x. So in this case, what's a little trickier is the negative 3, which I'm going to highlight right now. This negative 3 actually represents the y-intercept, even though it's listed first. The negative 7x over here is the slope term. So our y-intercept, or the y value here, is negative 3. If I were to make x 0, that whole negative 7x would disappear, and y would be equal to negative 3 if I were to make x equal to 0. The slope then, of course, will be the number, the coefficient of x, in this case the negative 7 that's multiplied with x, so the slope is negative 7, or we could call that negative 7 over 1, and I'm going to go ahead and put that negative sign out in front again. Okay, so we're going to see not always for linear equations that they're going to be in this y equals form, but a lot of times in 8th grade, 9th grade, they're going to be. It's the standard way we like to build a lot of our linear equations. And whenever it's in this form, a key thing to do is to be able to identify your y-intercept and slope. The reason this is helpful, or one of many reasons it's helpful, if you're asked to create a graph and the equation that they give you is in that y equals form. It's in slope-intercept form, like we're seeing on number 4 and number 5 in today's worksheet, and this is what you'll see on the 4th Khan Academy assignment this week. Understanding what the slope is, taking a look at the whiteboard here, and what the y-intercept is in the equation is the key thing to be able to make these graphs. Whenever I make a graph and it's already, or I want to make a graph of a linear relationship, the big thing is I need to do a few things. Number one, identify, I'm going to say identify the slope and the y-intercept. The second thing, once I know what the slope and the y-intercept is, I'm going to plot the y-intercept. That's going to be the first point for my graph always. I identify the y-intercept, I put that right on the graph because it's easy to find. And then the third thing I'm going to go ahead and do, once I found the y-intercept, I'm going to then use the slope to find other points. And we'll say more about that when we get there, but you start at the y-intercept and you use your slope to figure out where the other points for the graph would be. So here for our first situation, number 4, we have y equals 4x minus 3. So the thing I'm going to note, I'm going to put right underneath on my whiteboard here, the y-intercept is negative 3. That's that b that's all by itself. And then the slope is that number that's multiplied with x. In this case, the slope is 4x, or 4 multiplied with x is the slope term, which tells me slope itself is 4, or 4 over 1. So I'm going to go ahead and make this drawing larger. So if you want to edit the drawing, click on it, and then click this edit button, or you can just click twice on the graph. And give this 1 second to load. Now, again, looking back at my notes on my whiteboard, the equation was y equals 4x minus 3. That told me the y-intercept is negative 3. So the y-axis is this thing that runs up and down there. Let me make the whiteboard a little smaller so we can see the whole graph. The y-axis is what runs vertically. So if the y-intercept was negative 3, then in this case, the graph is going to start with a y-intercept of negative 3. So I'm going to drag this first gold point over here. The easiest way to move these points if you're at home, I think, is to hold your click right away. So hover over the point and don't click it once. Hold your click immediately, and then it makes it easier to drag the point around. Now, the y-intercept was negative 3, and I've plotted that point here. The slope, now I'm going on to the third and final step to make this graph. I'm going to use my slope to find other points. The slope is 4 over 1, or the rate of change. The m says y is going to rise by 4 on a graph each time the x gains 1 unit. So I'm going to take this next dot, and I'm not going to let it go. I'm going to start at my y-intercept and count up by 4 units, 1, 2, 3, 4, and also count right by 1 unit, and put that dot here. And what that shows me here is starting at the y-intercept, or the initial value of negative 3, we've gained 4 units as the x gains 1. Y goes up 4 as x moves right by 1. On Khan Academy, they really only make you draw 2 points or plot 2 points because there's only one way to make a straight line through 2 points. So once you had that, your graph is probably done. You could just draw a straight line that passes through those 2 points. I'm going to plot one more point. I'm going to go up by 4 units, and I'm also going to move right by 1 unit. And we see now that straight line form coming together. If I want to move this line, first thing I do is I click on the line once, and you'll see the 2 blue dots on top of it. If I hover my mouse over that blue dot, you see the cross gets a lot skinnier. And now I'm going to be able to drag that end wherever I want. And I can do the same thing with the other point. And it'll take a little bit of practice, but eventually you'll figure out how to draw a straight line that goes right through the middle of all these points. And now what this graph represents is all the different possible solutions to that original equation, y equals 4x minus 3. For example, we see that this point right here, x value is 2 and y value is 5. And if I go back to that original equation, if I were to make the x value 2, the y value would be 5. 2 times 4 would be 8. 8 minus 3 would give us 5. And every single point, every ordered pair that falls on this kind of gold line would represent one of the solutions to this equation. So that's what these graphs are really about, showing all the different solution pairs that could work for the representative equation. So we're going to do one more together using today's formula or slope-intercept formula. You can quickly build a graph with all the solutions for any linear equation they give you whenever it's in this y equals form. For our next one here, our last one, the green one, problem 5, I see the positive 5 is the b, that's all by itself. So my y-intercept is positive 5. That's the thing I'm noting on my whiteboard right now. 0 for x and 5 for y is the initial value in this equation. I also see a slope of negative 1/3. That negative 1/3 is multiplied with x. So I just noted quickly on my whiteboard here, my slope for this equation is negative 1/3. My y-intercept is 5. So to plot that then, I'm going to use the same procedure, the same steps. I'm going to go ahead, open this graph up, and the first point I'm going to plot is the y-intercept, that positive 5 value for y when x is 0. Thanks for being patient while this loads up. So as soon as it loads, I'm going to go ahead and drag this first point to the y-intercept of positive 5. And then I also need to use my slope. Now step 3, I need to use my slope to find other points. My slope is negative 1/3, which means my rise is negative 1. Y will lose 1 unit every time we go right by 3 units for the run. So I use that slope of negative 1/3. I go back to my initial value, my starting point, my y-intercept. I move down by 1. That's the y value losing 1. And each time y loses 1, the x has to have gained 3 units to make that happen. That's what that negative 1/3 times x means. Y will lose 1 unit, but you need 3 x's to make it happen. So now we see this line starting to move down to the right, like some of the negative slopes we saw earlier today. Whenever it's a negative slope, it will move down to the right. The bigger that x gets, the smaller that y gets. So there we see the straight line being formed by them. We start with a positive y-intercept of 5, but over time y is slowly starting to lose value at a rate of negative 1/3. I'm going to go ahead, click on this green line, and the last thing we're going to do is put a fancy line that draws nice through them. I'm using a little trick here. I know if I get up to the 7, I would have had to go 6 more left, so this line could actually start right on this corner there. And now, turns out as I go drag, it'll go right through the middle of all those. And again, this green line represents all the different solutions that could that would work in the equation we started out with here. Let me zoom back up to that equation. So any point, any ordered pair you pick out on this green line, for example, if I pick 6 for x and 3 for y, 6 times negative 1/3 would be negative 2. Negative 2 plus 5 would give me the 3 value that y is supposed to have when x is equal to 6. Alright, I hope that was helpful. If you've got questions, please feel free to send me emails and I'm happy to jump on and help you out. Otherwise, keep up the great work. And if all of this made sense, you should be in awesome shape to be doing all 4 of the first Khan Academy assignments this week. We'll be back on Thursday. Thursday we'll be talking about some of the stuff related to assignment 5 and 6 on Khan Academy. Thanks for